Today we're going to talk about angle pairs. The objective is I can use algebra with angle pair properties. And we learned about all the different types of angle pairs yesterday, like linear pairs, supplementary, complementary, adjacent, vertical, things like that. Example 1. Go ahead and draw an acute angle for me. Put in 26.8 degrees. And the instructions are find the complementary angle. And we do remember that complementary means sum of 90 degrees. Now, I know you probably don't need algebra for this specific problem. If I were to create an equation, though, and I drew the diagram so it actually went up and looked like a 90-degree angle, my algebra would be something plus something equals 90, and I put an x in that something spot. So, again, most of the time people know that, well, 26.8 degrees plus some angle is going to equal 90, and in their head they just say, oh, 90 subtract 26.8 degrees. But if I were to do the algebra and create an equation, because we are going to get to harder ones a little bit here in a minute, I would go and subtract 26.8 degrees from both sides. And my final answer would be x equals 63.2 degrees. Okay, on to some harder examples. Example 2. Go ahead and draw an obtuse angle here for me. And we're going to find the supplementary angle. Now this answer is not going to be as pretty. The first thing I'd like you to do is we do have to remember that supplementary means sum of 180 degrees. And I'm going to draw a little dashed line and actually show a linear pair that looks like I have two supplementary angles. Now here's a big mistake I see all the time. People want to put in the same variable. Now the thing about this mistake here, there's nothing in my problem that says whatever number this angle is has to be the same number that's in this specific spot. So really I cannot use y in my example here. So I'm going to go ahead and erase that, and I'm going to put in a different variable instead. I'm going to put in x. Now if I were to make an equation, my equation would be 2y plus 20 plus x equals 180. Because again, I know when I'm creating angle pairs, and I know they're supplementary, something plus something. In the first case, my something is 2y plus 20. The second something is x. I know it has to equal 180. And now I'm just going to solve using basic algebra skills. Subtract 20 from both sides, and I get 2y plus x equals 160. And now my goal is to find out, what is this angle here, y? And so I need to get x by itself, and the way I get x by itself is subtracting 2y from both sides. So my final answer is x equals 160 minus 2y. Now again, it's not pretty, it's not a clean answer like example 1 was. There are two variables in it, but y can be a changing variable. Whatever I do, whatever I plug in for y will affect the value of x. Okay? Example 3. Go ahead and draw this shape for me, please. Pause the video if need be. On the left, I have 29 degrees. On the right, I have 2x plus 1 degrees. Now, I did make a triangular shape out of this in the book, or worksheets will do this sometimes just to confuse you, but it's nothing more than a linear pair. So we're going to find x, and then we're going to find the measure of the angle. And I already know the angle on the left. I know that's 29 degrees. But I want to know what's the measure of this angle after I'm all done. Okay, we're going to create an equation. Since it is a linear pair and it's supplementary, something plus something equals 180. And all I have to do right now is plug in the somethings. My first something is 29. My second something is 2x plus 1. And my equation is, when I combine like terms, because I know I can put the 29 and the 1 together, I now have 2x plus 30 equals 180. This is two-step algebra. Everybody at this point should be pretty good at two-step algebra. Step 1 would be to subtract 30 from both sides, and I get 2x equals 150. Step 2, divide both sides by 2, and my final answer is x equals 75. Now, don't forget, we've only fulfilled one of the commitments here of find x. We also need to plug it back in and determine what the actual angle measure that is in degrees. So over here on the left, I'm going to plug it in. 2 times 75 plus 1. 2 times 75 is 150, plus 1 more is 151. And now I do a quick little check, and I make sure these two things right here actually do add up to 180. Whoops, never mind. Backtrack that. Not those two things. These two things right here do add up to 180. 151 and 29 do add up to 180 degrees, and my answer is correct. Example 4. Okay, a little bit of a crazy shape here. Again, pause the video if need be. And we're going to find x and find the measure of, this time, both angles. Because this time, I don't know what this angle is, and I don't know what this is. They're both unknowns. And you'll notice the diagram looks a little more complicated than it needs to be. Really, all I need is this part of the diagram. All this stuff on the left here. I don't really need the stuff below, but they add extra stuff every now and then just to confuse you. Now, I do have to notice that these are complementary angles, so they add up to 90 degrees. So my equation, the basic form of my equation, is going to be something plus something equals 90. The first something will be 3x plus 1. The second something will be x plus 9. And now I have an algebra problem. I do have to identify that I can combine like terms. 3x plus 1x is 4x, and when I put the 1 and the 9 together I get plus 10. So I have 4x plus 10 equals 90. And now again we're just back to two-step algebra. Step 1, subtract 10 from both sides, and I get 4x equals 80. Step 2, divide by 4, and my final answer for the first part of this is x equals 20. Now, we have two options here. I could plug 20 into one of these, but then I wouldn't know if I made a mistake somewhere down here in the math. So I recommend plugging it into both. So here's the first plug-in. 3 times 20 plus 1 is 61. And then the second plug-in is 20 plus 9 is 29. And again, I can check these real quick and make sure, do these two numbers, actually add up to 90? And they do. So I know my work is correct. Example 5. Okay, this time I have what are called vertical angles, two intersecting lines and the angles across from each other. I'm going to add two little arcs here, arc 1 and arc 2. I can do that because we know the fact that vertical angles are congruent. Now, the last couple equations we had, complementary, something plus something equals 90. Supplementary, something plus something equals 180. This equation is going to be something equals something because the two angles are congruent. The first something is 2x minus 18. The second something is 4x minus 68. Now, this again is some basic algebra. I do need to get all my x's to one side. I'm going to do that by subtracting 2x from both sides. And I get negative 18 equals 2x minus 68. And again, now we are to a two-step equation, which we should all be good at. Add 68 to both sides, and I get 2x equals 50. Divide both sides by 2, and I get x equals 25. Okay, phase 1 done. Now phase 2, I got to plug them back in. First one, 2 times 25 minus 18 equals 50 minus 18, and I get 32. Now, don't just stop here. A lot of times people will make some errors down below here in the algebra. They'll plug it into one and say, well, the other angle must be 32. Actually go back and plug it in and make sure they're both 32. 4 times 25 is 100, minus 68 is 32. These angles are the same degree, so I know my final answer is correct. Example 6, a story problem. An angle measures 3 degrees less than twice the measure of its complement. Find the angle measure. Okay, so if I were to draw a little complementary angle here, I've got angle A, I've got angle B. So the problem with this is if I said angle A plus angle B, equals 90, and then I threw in this stuff about, oh, well, the measure is 3 degrees less, twice the measure of its complement. So I could take B and multiply by 2 and subtract 3, but I still have two variables, A and B. Okay? So the first thing I'm going to do is I'm going to change those variables. I'm going to change A to X, And then I'm going to change b to 90 minus x, because it doesn't matter what I put in for x. If I want to know its complement, if I subtract that number from 90, it gives me its complement. And then when I make an equation, I've got something that looks like this. X equals 90 minus x. Now I throw in the times 2 minus 3. So 2 times its complement, here's the complement right here. Subtract 3 degrees less up here, is equal to the angle. And now I have an algebra problem I can solve. Go ahead and distribute 2. I get x equals 180 minus 2x minus 3. I do have some like terms here I can put together. X equals 177 minus 2x. Now I'm in a scenario where I want to get all my x's on one side. I would probably add 2x to both sides, and I get 3x equals 177. I'm running out of room, so I'll go up to the right here a little bit, and I know the final step is divide both sides by 3. And so for measure of angle A, I get x equals 59. Now, if I take 90 minus 59, I get 31. And now I can do a quick little check, and I can see, well, if I take 31 and I multiply it by 2, so 31 times 2, and I get 62. And then if I subtract 3 from that, do I get 59? And yes, I do, so I know the math works.